So although this is heron again, couldn't help myself and had to do some experiments after I handled that small cross hammer and realized that it doesn't corrode in any way. I'll try to make some experiments on the corrosion resistance of that alloy. I will try battery acid. It should be around 30% sulfuric acid. I will try sodium hydroxide, and I will try 9% sorry. I will try 9% ammonia solution. And yeah, we will see how this material reacts to that. I will slice a small piece. I just sliced one here. It's still quite hot. So it's cuttable with a bandsaw, no problem. Actually cuts well. So we'll also try to machine the rest, but first I will slice some or make some slices like this, some small discs, and polish them on one side. On one side I will leave them just saw cut, and then I will throw them into yeah, those three things. And if I don't get an immediate reaction, I will just wait one day and show you the results. So we will see. So I cut a few slices and I polish them from one side, and it cuts actually quite well, so I will do some machining experiments maybe tomorrow, but this is just a small thing. And yeah, my hand got a little extreme dry from the plaster and mortar stuff, and yeah, dust, and yeah, typically not what I'm doing, but it has to be done. So yeah, here it is. Well, I'll polish that up and throw it into the corrosive substances, corrosive solutions. I mean, I have to make a solution. Yeah, this is powder or granulate, and yeah, see how that reacts, because it seems to be, as Craig mentioned, a really nice material for jewelry, because it's also nickel free, so there should be no problems with allergic reactions or something like that. And if it withstands all those quite aggressive substances, should be fine. I mean, at least for jewelry. I mean, boiling acids or something like that in high concentrations, it will be another story, but I'm just testing the extremes of a normal use with this acidic, alkaline, and some ammonia stuff, which tends to attack copper-based alloys. And I cut 4 slices, so I will put one in saturated salt solution, just plain table salt. See what happens. So let's start with the experiment, and I will show you if there's immediate reaction. I mean, I will polish the stuff first. It would take me an hour or so sitting, watching some YouTube videos and polishing it up by hand, and then, as I said, I will polish one side, leave the other side rough, and you can see it isn't that brittle. It broke off at the end. But it's a really shallow or a small area, and this piece is quite thin here, so I can't really break it like that. So, bah, it stings. The 9% ammonia is low. I mean, it's not the really bad stuff, but so now we have here, this is saturated salt solution, battery acid, sodium hydroxide solution and 9% ammonia solution. I will now put the test pieces in. By the way, they polished to a mirror finish more or less, no problem. So let's put them in. The salt water shouldn't hurt me at all. This is the battery acid. This is the sodium hydroxide and the ammonia. So I don't see any immediate reaction. All seems to be calm. So if nothing happens, I will just leave them in there for a day and then see how they react. About 20 minutes in there. Cannot really see any reaction. The colors look slightly different, but I noticed that in the first place, and I think it's because of the different absorption of those solutions. So it's looked kind of yellowy in the sodium hydroxide in the first place, and it didn't change since then. So I think it absorbs a little more of the blue, and the ammonia also nothing. So I will leave this overnight and we'll see the final result. By the way, after cutting some of those slices with a bandsaw, I just made a machining test and it kind of machines okay. I think with carbide or so should be no problem at all. The cheap high-speed steel dulled up a little bit, but when it was cutting, I was pushing it a little fast for this material, so also without cutting ore. So just a rough test. And it kind of looks good so far. So I will be back tomorrow, or in a second, due to the magic of filming something. And then we will see. Bah! Ammonia. Not good. So it's been a day now. And I've just removed that. Cleaned it up a little bit. So you can see there's a color change in the one from the battery acid and in the one from the ammonia. The salt water and the sodium hydroxide is not touched. The solutions, the ammonia solution turned blue, interestingly. So I was thought that I had the camera on when I took them out, but yeah, you can see it's untouched, slightly coppery, untouched and slightly dark. And 24 hours now. The copper turned immediately to that color, and then it seems to be passive. The ammonia wasn't visibly reacting after 20 minutes, but after 24 hours the solution turned blue and the metal a little bit dark. So it seems to be a viable or alloy that can be used for jewelry, especially considering that it can be polished to mirror finish. It's hard enough to not scratch that easy. It seems to be corrosion resistant enough. Can be cast, and it turns or it gets oxide coloration like titanium when you heat it. So I think I will put them back in to see the reaction after 2 days. Especially I want to see whether the reaction with the ammonium stops due to the buildup of a passive layer, or if it continues, because the reaction with the acid seems to stop. And now it's basically, yeah, it didn't change from after 20 minutes after I put it into 24 hours in the acid, There's no visible reaction after the first slide and turning reddish, coppery. So that is for me a little update on the corrosion resistance of that material. And yeah, we'll just put it back in and see what happens in 2, 3, 4 days, just to see whether it stops or not. I mean, those two colors are not bad, and it doesn't seem to really attack the material, it just colors it. So I think there will be a buildup of a passive layer or something like that to stop the oxidization from going on after a while. So yeah, we will see. So just put them in. Again, I will check them every day, record that, but I think I will upload this step now. That will be the end of the video. A small update on the experiments on that 12% titanium alloy. 12% titanium and copper. So yeah, seems to be interesting stuff. Also, I found some papers about the use of 4% titanium and copper for replacement of beryllium copper, and it seems even to have better properties for conductive springs and non-sparking tools than the beryllium copper, so I will try that out. Could be a nice material. And yeah, that's basically it. I will continue to test this. I'm also planning to set up investment casting vacuum setup, but I think it will somewhere in the summer. I have to do other things first here in the workshop, set up a drill press and things like that. The work on the house is nearly finished, so I should be able to continue experimenting around here a little more, with a little more time in the next weekend or so. So yeah, that's it for me right now, and hope that was interesting. At least it was interesting to me. And see you in the next video. Thanks for watching.